Hey, good evening, everyone. Welcome to Pittsburgh.NET user group. We are part of the .NET Foundation, and the social links are here. We are on Meetup, and then we are on Twitter and LinkedIn, and we do host meetups every month. So feel free to join us here. And today's topic is going to be Introduction to AI from Developers. I'm Sam Nasser, my good friend and neighbor from Cleveland, is presenting today. Hey, welcome, Sam.
Thank you. Thank you for having me. Great to be here.
Thank you for taking time today.
Absolutely. Should I go ahead and share my screen at this time?
Yeah, yes, please.
All right. All right, very good. All right, well, good evening, everyone. Thank you all for joining us, and thank you to Bala for having me again. It's always a pleasure speaking with this group. Wanted to get started with tonight's presentation, and that is going to be on Intro to Artificial Intelligence, specifically for developers. A little bit about me. You can find me on Twitter or X at Sam Nasser. I've been a software developer since 1995, and I'm a senior software engineer and trainer for NIS Technologies. I've been certified with a few certifications from Microsoft. In addition, one of my biggest prides is running the Cleveland C# user group, as well as the Azure Cleveland user group. I've also been an author for Visual Studio Magazine, and I am a 7-time Microsoft MVP in the AI field. A shameless plug, if I may, for the Azure Cleveland user group, as well as the Cleveland C# user group. We meet every month. The meetings are free of charge and open to the public, and you can find the meeting information posted at meetup.com at the links listed at the slides. At the bottom of the slides. So diving into tonight's presentation, I wanted to look at an overview, and I think the first thing that we need to do is probably get this alphabet soup straightened out. So you may have heard AI, ML, deep learning, NN or neural networks. What do all these things really mean? Certainly it seems like alphabet soup, but as we see in this diagram, it helps to kind of put everything together in perspective, meaning that we start with neural networks, we build on that, we get into deep learning, and then a bigger set of that would be machine learning, and then we expand into AI. So as you see, it is basically layers of the onion that build upon each other. Having said that, let's take a look at neural networks and dive a little bit deeper into what they are. So basically, with neural networks, essentially you have an input layer, and then you have other hidden layers in between the input and the output layers, as we see the 3 columns over in the middle, in between the input on the left and the output on the right. Now, what happens is basically the input layer will take a feature, meaning some kind of an input, and it will go through the processing, basically a decision tree in the middle there. And as you see, we can go from one hidden layer to the other, and then eventually we proceed out to the output. More specifically, if we were to define that into layman's terms, what does that look like? Well, let's take, for example, let's assume for argument's sake that I am a professional web surfer, a professional surfer rather, and there is a couple things that I need to take into consideration when heading out and hitting the waves. So first of all, I would need to consider, are the waves good? That's obviously a key criteria if I'm going to be surfing. And if it's a yes, then I assign that a value of 1. If it's a no, I assign that a value of 0. Next, I want to look and see, is the line empty, meaning is the beach overly crowded, or is it empty? Am I going to be able to get in on my surfboard and hit the waves, or is there going to be a long wait? And then last but certainly not least, is it a safe area, meaning that there are no shark attacks? Obviously, that's a key factor. So is it safe? Yes, that's a 1. If not, I assign that a 0. Now, all these are 3 important criteria for me, but they're not equally weighed. So I can assign weights to them to see where they lie. So since I am a very strong avid surfer, I am looking for big waves, right? So I assign that a weight of 5. As far as the line is empty or not, yeah, I'm willing to wait. That's not that big of a deal. I'm willing to sacrifice it. So I would assign a weight of 2 to that. And then the shark attack, that is high on the list. So I would assign that a weight of 4. And let's say for argument's sake that once I calculate all these using the ones and the zeros multiplied by the weights, I'm going to have a threshold of 3, meaning I'm going to go surfing if it is a value of 3 or higher. So as we see at the bottom, I will assign a yes or a no to all these weights. So the waves are good. I'll assign that a weight of 5. Is the line empty? No, it's not. There's people there. So I'll assign that 2. And then with a shark attack, is it safe? Yes. Okay. So now I have, and I subtract the threshold of 3. So now I end up with a value of 6. So now that is a positive that I am definitely going surfing. So essentially with a neural network is that I am taking all these decisions that we see here in green that are in the middle, and I start with the input layer where I input in my decisions of what I want to go surfing, if the line is empty, if there's a shark attack, and then I have an output layer with a final number, and that will determine if I go surfing or not. So that is a neural network where I have decisions that are being made based on the input and the weights that are assigned, and then I get an output value. So in layman's terms, that is essentially what a neural network is. Now, obviously, that is very simplistic, but obviously there are more factors that go into play. Is the water temperature good? Is there a lot of daylight left? Are there a lot of surfing veterans out there, or are there amateurs that I might be colliding with? So that could add more to my neural network and expand the nodes. And again, those factors would also be assigned weights. So that is a neural network at its core. Let me just pause here and see if there's any questions. And currently I don't see any in chat. And Bala, I would appreciate it if you let me know. Feel free to interrupt me if there's any questions that I may have overlooked.
Yeah, we'll do. Absolutely.
Appreciate it. All right. So if there's no questions, let's continue on. And going on to the next portion of our slide. Now we've defined what our neural network is. The next layer would be deep learning. So what is deep learning? Deep learning is also known as deep neural learning, and it's a subset of machine learning. So it's right between neural networks and machine learning. And it's a superset of neural networks, meaning that if I have more than 3 layers of neural networks, then that would be considered deep learning, meaning there's a lot of decisions that need to be made and weights to be accommodated for, and that will lead me into a deep learning state. So I am no longer just evaluating, is it safe from shark attacks? Is the line empty? Are the waves good? But rather I am also looking at a lot of other factors, temperature, are there veterans that are out there? How much daylight is left, et cetera, et cetera. So now it's building into a deep learning network. And the whole point of this is it analyzes factors similar to a human neural system. And if you think about it, these are things that we may think about whenever we're deciding to do something, whether taking a trip to someplace for vacation or going out surfing. These are all factors. There are multiple factors that we take into consideration, even though we may not consciously admit it, but there's a lot of subconscious questions that we ask ourselves that we go through before determining whether we want to proceed with something or not. So that is essentially deep learning. Now, let's turn our attention to some terminology.
Sam, there is a question if you want to take it.
Sure, go ahead.
Does the number of layers to define deep learning include the input and output layers?
No, it is simply the number of decisions in between, because with the input layers, essentially, well, you could have multiple features that feed into it, but with the neural network, essentially you're looking at what decisions are going to be based on what. And so you could say that it's also including the input layers, but the output typically is just a single field, if you will.
Perfect. Thank you.
You're very welcome. All right. So with regards to terminology, when we say that there's a feature, basically that is input for a machine learning model. For example, if I am in the process of buying a vehicle, some of the features that I may look at are the size of the vehicle, the mileage, and or other attributes that pertain to something that could affect the final price of the vehicle. A label is essentially the output or the price. So I give it the size of the vehicle, or whether it's a V6 or an 8-cylinder, whether it's a sedan or a SUV, and then it would help determine the price of the output, or the output rather, which is the label. So that process that happens in between is also known as the transform, and that is the type of prediction that it is doing in the machine learning model. Now, that was a very simplistic transform that I provided, but there's actually many other transforms that are available. Specifically, some of the machine learning scenarios are classification and categorization, where I can take customer feedback and define that as either positive or negative. I can look at regression, meaning I can look at, see, for example, the price of a used vehicle as mileage increases and age increases, so that price decreases. So it's an inverse proportion there. I can also look at anomaly detection, and this is useful for detecting fraudulent transactions. For example, I admit I shop at Costco weekly, and typically for every bill, it's about $150 to $200. Now, my credit card company is kind enough that they're monitoring my transactions. And if it ever shoots up to above 1,000, for example, that's obviously an anomaly. So I would get a phone call and say, was this something that you had charged, or has your credit card fallen into the wrong hands? So it helps to detect the anomaly based on fraudulent transactions and based on history as well. Another machine learning scenario is recommendations. I'm sure we've all heard of a website called Amazon.com. That's another place where I shop frequently. And with every purchase that you make, it makes recommendations on other things that may go along with it. For example, if I buy a lawnmower, it can suggest an edger or a weed whacker, various things like that that tend to go along with that same purchase. I can look at time series and sequential data. So this would be useful for forecasting. I can look at sales from the past and kind of create a regression model to understand how sales increase. Or I can see the peaks and the valleys. For example, with flower sales, those obviously peak during Mother's Day and Valentine's Day, but then they tend to level out during the rest of the year. And then last, but certainly not least, is image classification. This is where I can categorize images in a variety of ways. I can look at an image and say, this is a cat, this is a dog, but I can also use it for medical purposes, for an X-ray image that may look like it's something cancerous and may need to be addressed further. So that can help me categorize an image into one category or another. I want to pause for a second and see if there's any questions. And if not, we can continue on. All right.
Nothing yet.
Very good. So this is for the various machine learning scenarios. So how do I develop a machine learning model? Essentially, that is a cyclical process. And what I mean by that is, if we look at the diagram here, we start by collecting and loading the data. Then we create the pipeline. And then we train it. So now we have a pipeline of data. We train it on that data that is given, and then we evaluate it. We evaluate it by giving it a sample prediction. And if we're satisfied with the result of that, then we can continue on at the bottom section where we can save the model and then deploy it to our end users or our development team to continue to use that model. If we're not satisfied with the results that we received, it becomes a cyclical process where we load in more data, create the pipeline, train it, and then reevaluate it again. So essentially, we're training and reevaluating repeatedly until we're satisfied with the results. Some of us have children, and obviously they all have homework when they come home, and we want to keep an eye on them to make sure that they're ready for the exams, right? So what do? We give them practice problems, and we see that the results that they're producing are correct. If not, we give them more problems and put them to the test to ensure that they can actually solve those problems. It's the same way with the model development. Now, if I'm satisfied with the training process and the evaluation, then I can save the model down on the bottom here using the save method. And this will essentially save the model as a zip file. And then this can be used in my .NET projects where I can use it to make predictions. So once that model is saved, after it's trained and evaluated, now I can use it by essentially taking that model, loading it into a .NET project, and then being able to make a prediction using the create prediction engine class and the predict method. So this is essentially machine learning in a block diagram. How do I really implement that when it comes to code? So for starters, to do that, I would need to install the, within the .NET desktop development environment, I would need to have the ML.NET model builder as we see over on the right-hand side. So that needs to be installed. And I would do that through my Visual Studio installer. Once that's set and it's in place, now I can create a machine learning project in .NET using one of three methods. I can do it by adding it in the GUI, in the UI, where basically I have a project, and then I would right-click on it and then select add. And instead of selecting a class, rather I would add in a machine learning model. Another way I could do it is programmatically by incorporating the Microsoft.ml NuGet package, or as with everything else, I can do it through using the command line interface. Okay, so three separate ways. The prerequisite is that I install it ahead of time and I specify that I want the model builder in my desktop development environment. So having said that, let's jump into a demo. And what I have here is I have Visual Studio 2026. I have a console application that is completely bare bones that I had just created. And what I'm going to do, as I mentioned, I'm going to right-click on the project. I'm going to select Add, and then select Machine Learning Model, as we see here in my context menu. I'm going to select the default name, mlmodel1.mbconfig. We'll go ahead and add that in there. And now it's going to walk me through a GUI interface where it's going to ask me various things. What type of scenario of machine learning do I want to implement in my solution? And as we had said in a previous slide, there are many various scenarios that I can implement. So we have data classification, image classification. We can also do natural language processing, et cetera, et cetera. So what I'm going to do is I'm going to utilize the data classification. And what this will do is it will categorize my data. But before I do that, I wanted to point out that you'll notice for each type of scenario, I see that there's a local here, meaning I can run it locally, or I have the option of running it in Azure. So I no longer have to be worried about my own computing resources, but rather I can utilize the horsepower in Azure. So for this scenario, I'm going to select the data classification. Now it's giving me a brief rundown of my environment, how much memory I have, the type of processor. And we'll go ahead and proceed to the next step. And here it's going to ask me for the data. So for the data, it is a sample file that I have. Give me 1 second to dig that up. It is going to be in my presentations folder. There we go. Intro AI, demos, data. And there's a file here called yelp-labeled.txt. So before I select that file, I want to open it so that you can see what it is that I'm working with. And it is a flat file, text. Basically, it's tab delimited. It consists of 2 columns. There's a raw comment here in natural spoken English, and then there's a field of either 1 or 0 that indicates whether the comment is positive or negative. So this is what's called supervised learning. I'm giving it a phrase, and I'm telling it that this is a positive comment. I'm giving it another phrase and telling it this is a negative comment. Again, think of how you would train your 3-year-old. You tell them this is a good word, this is a bad word, this is a nice thing to say, this is a bad thing to say, right? Machine learning is the same thing. This is what's called supervised learning, as I mentioned. So this consists of 1,000 different comments, all fictitious for a pizza restaurant. And we see various comments here, some that are positive, others that are negative. So we'll go ahead and import that file. And now it's going to ask me, which column do you want to predict on, meaning the label. That label, if you recall from the terminology, that is the final output. So the label would be column 1, because this is 0 relative. So column 1 is the output, meaning positive or negative. Column 0 is the actual text that's being used. And it's giving me a preview of the first 10 columns here. I'll go ahead and click next step. Now it's asking me, how much time do you want to spend training on this? I'm going to go for 10 seconds, and we'll click the start button. And as we see down in the output window on the bottom, it's going to utilize various trainers for a specific machine learning model. And it's going to go through, and it's going to tell me the accuracy that it came up with. So after running it for 10 seconds, we have it figured out that the best model to use was the Fast Forest OVA. Actually, I think this is an abbreviation. And it took 7.79 seconds. It explored 5 different models, and this was the best trainer that it found. So it has a confidence score of 0.71 or 71%. Now, the next step after training is evaluation. So I will, it automatically entered in the first line of text from the file, which is crust is not good. I'll go ahead and click predict. And then it tells me that 87% confidence that this is a negative score. And it's only 13% confident that this is a positive score. Now I'm going to enter in something in at random, and I'm going to say, I hate this place. Okay, so I see that it came back with an 89% score that it's positive, and that is obviously wrong. So in this case, I can train it again on additional data samples. But let's assume that we're satisfied with the 0.71 or 72% here for its accuracy. For the sake of time, I won't retrain it, but rather we'll move forward. And we'll go on to the next step. Now it's walking me through, and it's saying that I can utilize this model that I created, and I can do it in a variety of ways. I can consume it using this code snippet that I see here, or I can add it in as a project into my console app, or I can add it in as a web application to my solution. So I'm going to go ahead and say create it as a console app to my solution. But before I do that, I want to point out that I currently have only one console application called console app 1. And all it contains is the model1.mbconfig and program.cs. Okay. So this model MB1 config, that is essentially all the GUI that I went through. And essentially, this is an XML file that contains all my various selections. So I'll decide that I will add this as a console application to my solution. And once I do that, you'll take a look over in the Solution Explorer, and you'll see that there's another application that will be created. So what's the project name that I want to call it? We'll accept the default name of model1_console app 1. And we'll go ahead and add this to the solution. And as you see, everything has been added over to the right. Now that I have a second console app, I can go ahead and open up that program.cs. And we see that it created a program.cs. And we'll make this as our startup project. And then when we go ahead and run it, basically in this program.cs, oops, wrong one, over here, what it's doing is, sorry, there's the command window loading up. Basically what it's doing is it's instantiating a version of the model1.input, which if we look over in Solution Explorer, we see that we have the ML model 1 here. And in program.cs, we're going to be initializing that ML model. We're going to pass it in sample text and say crust is not good. And then we're going to get the prediction where we're taking in that sample data. There's the sample data that we defined up here. We're taking it in and we're calling the predict all labels. And then we're going to display the output and the confidence score of that output. And so with that, we take a look at the output and we see that we're passing in crust is not good. The final result is that it's a negative comment. And then it shows us the score here of 87.4% confidence that it is a negative comment. Okay, so what I did was I walked through the GUI, selected a few items as far as the data file that I wanted to import, the type of machine learning scenario that I wanted to implement, and then how I wanted to implement that code after it was trained. And there I have it in my ML.NET solution. Okay, let me pause here and see if there's any questions. And so far, none. All right, so either, sorry, go ahead.
Question or
anything
for
our
of the web
JetBrains
application. Oh, sorry, go ahead.
Okay, sorry. So there's a question, anything for our JetBrains guys? I was thinking of a web application and making a background job that would create this. Do you have any roadmap? My point is to automate the process. Okay, so you certainly could automate the process by importing the data. You would have to put in some checks that you're satisfied with the output. Typically, there's a process, you've heard of DevOps. There's also what's called ML ops or machine learning ops. And this is an automated process because if you think of a large organization or enterprise, they're constantly adding more data to their systems on a daily basis. Think of Amazon, for example. Their sales are never ending. They're constantly selling and adding more to their data. So if I want to build my model based on that data that I'm getting, I'm constantly updating it with new customer data. And so that is an automated pipeline process where I'm taking in the data, training the model, evaluating it, and then pushing it out either into production or having my developers take that and incorporate it into their applications. So yes, this can all be automated. Now, I skipped one important step, and that is intentional. That is the data cleansing part. Data cleansing is a whole different session that we could spend literally hours on. But assuming the data that I have here is sanitized, I can implement it in my solution and train it. And yes, the process can be automated. And you can do this in a variety of ways. You can obviously custom build your own solution, as I did here in .NET solution. I can also utilize a pipeline in Databricks or in Microsoft Fabric, or a lot of the other third-party tools that can help me implement this in a more automated fashion. Does that answer your question? All right, I'll wait for your feedback or any follow-up questions. In the meantime, any other comments or questions? All right, and if not, we can proceed on. All right, so I'll close this and then looking at our slide deck. So if we want to improve our performance of our data, as we saw here, it started off good, but then I threw in a sample and it didn't react positively. So how can I improve the performance of my machine learning model? First off, I can provide it with more data, but not just data. It needs to be clean and meaningful data, data with context, more specifically. For example, what I mean by that is, if I was to tell you that I bought a home, or if I ask how much is the price of a home in the Pittsburgh area, well, it depends where in the Pittsburgh area. Is it in the good part of town or is it in the bad part of town? How many bedrooms does it have? How many bathrooms? Swimming pool? Does it have tennis courts? Et cetera, right? Likewise, it could also be a low-priced home because of a variety of other factors. Termite damage, fire damage, could be in a flood-prone area or earthquake-prone area, right? So all these things would help dictate the price of the home, and so that is the context that I need for that data. I can't just look at number of bedrooms and the price of the home. I need to look at the overall picture and put things in context. And when I say clean data, again, that is something that I'm a big advocate of cleansing the data ahead of time. Unfortunately, we don't have time to go through this, but that is an entire process with various ways of filling in missing data and calculating the missing values. So that is definitely a topic for another time. Another way I can improve performance is by using something called cross-validation. So this is a model evaluation technique that essentially splits the data into several partitions, and it trains using multiple algorithms on those partitions, and then it compares the results. And then this can be an effective tool for training the models with a smaller data set. Another option is to consider different algorithms. As you had seen when I was training my model on those 10 records, it went through 5 different models for training. And then it gave me the best result based on the time that I specified. I can also increase the amount of time that I spend training it, and that would also help to improve the results. Okay. And again, not seeing any questions in chat, and so we'll continue on. All right, so going back to our layers, as we see here, we started off with the neural networks. We talked about deep learning and then machine learning and how we can incorporate that into .NET applications. But now we've heard of something called AI, I'm sure, right? And it's been around for many years. So what is AI? So there are what are called Azure AI services, and these are services that provide human interpretation. So it mimics human behavior and the interpretation of the data that it is given. And it builds upon all those layers that we had seen earlier, based upon neural networks, deep learning, and machine learning. It encompasses all that. And now I no longer have to just give it a number or train it, but rather it is now a human interaction in the same way that I would talk to a colleague, ask it a question, get a response back. So these are available as services in Azure AI. And they're used for building intelligent applications. So I can, again, interact with it in the same way that a human would. And there are no data science skills required. It's a matter of just simply speaking and communicating with it and then getting the results back almost instantaneously. So to utilize AI services, essentially the models are built using the external portals, and it's linked to the Azure account. So we'll talk about the Microsoft Foundry in just a little bit. That is linked to your Azure account, even though it's an external portal, and I can build many things within it. Everything that I build in the Microsoft Foundry is linked back into the Azure account. So I can also have access to these APIs or these models using SDKs through the cloud. So they are deployed in the cloud, and then I just make a couple API calls using the SDKs, and I'm able to access the results. So some of these services include vision, decision-making, language and interpretation, speech, and a variety of other services provided by OpenAI. More specifically, looking at speech services. So this is what I consider very low-hanging fruit, and we'll see it in just a second. So with speech services, there are 4 different things that I can implement with that, and that being speech to text, text to speech, the translation, or I can even use speaker recognition, which basically allows me to identify and verify the people speaking on audio. So if Bala and I were having a conversation, I could feed it in as an input, and then it would identify who's talking and what they're saying. So this is something that would need approval before implementing the application, but I can easily show you the other 3 services that are available. So getting into a demo, again, going into my .NET application, and let's start with speech to text. And basically, I am utilizing 2 things for doing this. So I have my subscription key, and I also have the region that I'm implementing this. Now, the subscription key is something that you'd want to keep hidden. So this is over in my app settings file, as opposed to having it right on the screen. And then from there, I'm specifying what input device I'll be using, which is going to be my default microphone. I will then call the speech recognizer. And then from there, basically, I'm going to go through an infinite loop here where it's going to ask, how can I help you? And then I'm going to do a wait, recognizing the voice of the speaker, and then displaying the results, and then asking the user to press enter after I display the results. Okay. So we'll go ahead and start that. And there's my output window. And as you see, there's the comment that I had just stated, right? And this was, oh, I'm sorry, this was, forgive me. I talked about speech to text, but I had speech translation as the startup project. So let's go to speech to text. And it is a similar format where, again, the 2 key things that I need to utilize are subscription key and region. I'm instantiating the speech config with my subscription. And then from there on, like I mentioned, it's an infinite loop where I ask what I can do for the user, how can I help you? And then I display the text that they spoke into it, and then they can press enter to continue, and the cycle repeats. So we'll go ahead and start that up. So this is speech to text. How can I help you? I would like to order a large pizza. And there's a text that I just spoke into the microphone. I can press enter again. I would like to speak to your manager. And there's the text that was entered in. Now I can take that text and then further process it within my application to either send an email to a manager or notify a supervisor. So obviously, this is the reason I called it low-hanging fruit is because it didn't take very long to implement, right? I went into Azure Services, set up my service, got a subscription and a region, was able to instantiate it, and in approximately 15, 20 lines of code, I'm able to implement it. And here I am using the SDKs as I had mentioned. Okay. So relatively low-hanging fruit. Now this is useful for someone who may not be able to type in the question or a comment. They can actually speak into the application, and then I can do further processing from there, like I said, to email a manager. Another useful feature within speech is the speech translation. And we'll go ahead and set that as my startup project. And we'll hit start. I would like to order a large pizza. And there it gave me the original text, as well as in the 2 other languages that I had designated being Italian and French. Taking a closer look at the code. Again, this is the norm where I am utilizing subscription region and then instantiating the translation from the keys that I had obtained. I am setting my language to be English US, and I'm adding a target language of Italian and French. And then I'm going through an infinite loop here where basically I'm asking the user to speak into the microphone. I'm translating and displaying the results, and then repeating again after they press continue. Okay, so again, within approximately 20 lines, actually make that a little bit longer. It's a little bit longer than that, so about 40 lines of code, but again, not something that is completely out of reach. So this is handy if I'm working with international customers and I have a language barrier either between my customer service reps and the end customer. This is a good go-between, and I have complete control over it, completely built within my application and utilizing the Azure AI services. Okay. Let me pause here, see any questions? All right. If not, onwards and upwards. Some other things that I can implement with AI services is custom vision, where I can actually do object detection within an image, meaning I can walk into a electronics store and I say, I need to order one of these. I have no idea what this is called, but I need to buy one of these, right? So I can take a picture of it and send it and say, this is what I need, and it would detect the phone within that image. I can also use computer vision, which analyzes content and images, or using OCR. So I can hold up an item like this with wording on it, and then it would take that and do OCR and translate that. Another thing is facial recognition. So this can be used for security purposes where it would only recognize me, and it doesn't necessarily have to be just this face with this shirt and glasses, but rather there can be various variations. We'll pick up what the facial features are. In addition, other than identifying people, it can also identify the emotions in the images. There's the video indexer, which analyzes video and index content. And then there's form recognizer, which will extract document information from the file that you upload, whether it be an invoice or a receipt, and it can extract that information from it. And then there's also the ink recognizer, which does handwritten recognition. Now, specifically regarding face detection, as I mentioned, it identifies the face within an image, but then it replies back with not only where the image is located within the image, but also any emotions that may be portrayed, as well as the image or the face of the image of the person. Meaning here we have a 23-year-old female, and that's what we get back. And you'll notice the result set is all in JSON, so I can parse it within my .NET code. Expanding on that within object detection. So here I have an image of a lady using a computer, and there's various objects around her, such as a toaster and what appears to be a crock pot. And so within my JSON object, I see the location of where these images are located and what it identifies those images are. So I see kitchen appliance, computer keyboard, laptop, and of course, person. Okay, so these are the AI services that are available within Azure, and more specifically within the Microsoft Foundry. Now, building on that and taking it to the next level are the large language models, which is obviously within AI. And what LLMs are basically models that are trained on vast amounts of data. And what I mean by vast, I'm talking almost the entire internet, essentially. So you can have a conversation with it just like you would with a colleague. It generates text, and that's why we call it generative AI. So it's human-like text responses. It translates languages, can summarize information. You can actually have a give and take with it. And more importantly, you can customize it for your own purposes and your own data. So this is useful when creating a chatbot or trying to build a specific customer service experience. And this obviously utilizes billions and even trillions of nodes. The example that I gave you much earlier in the neural network was 3 examples of what I used to evaluate if I was to go surfing, right? Now we are talking about a large language model that is in the billions and trillions of neurons or nodes that are used to build this intelligence. So when I'm interacting with a large language model, this is all done using what's called tokens. Tokens are basically what are called a basic unit of text, and it could be a portion or the entire word. And they are used by the model to understand what the user's intention is, and then they're also used to generate the output as well. So it's either a word, part of a word, a character, or even a punctuation mark. This is all dependent on the model itself. Each model will split up the input into various tokens depending on how it's structured. So not all models look at the same text and the same number of tokens. And I'll show you what I mean by that in just a second. But essentially, tokens are used by the LLMs for both training as well as input and output, or inference and generating the output. So let's take a look at an example of that. And first, I would like to show you an example of tokenizer. And let me expand my screen. And we'll go to tokenizer. So this is an example by OpenAI, and I'll click the Show Example button, and it will enter some text here. Now you'll notice if I'm using the GPT-5.x family of LLMs that these 252 characters will essentially be 53 tokens. And as we see here, it seems like every word is a token by itself, right? Things like the punctuation that we see here with the colon or the period, each one of those punctuation marks by this LLM is considered a token. Now, if we switch families, keep an eye on this number of 53 tokens and 252 characters. If we switch to the GPT-4 legacy, we see that it is still 252 characters, but it is now 57 tokens. If we go further down into the legacy hole, then we have 64 tokens for that same 252 characters. Okay, so each model family divides up the characters into different tokens depending on how that model is structured. Having said that, let's go take a look at our chat playground, and more specifically in the Foundry. So the Microsoft Foundry is, again, that's another topic that could take a while to discuss, and it's a subject matter all in its own. There's a lot that can be done within it. And one of the things that I want to show you is the model catalog. I'll open that up in a new tab. And if we jump over into the model catalog, we see that we have 11,426 models, right? And that list continues to grow. I can filter on which model I want to use depending on the capabilities of what I want it to do, whether it's for reasoning, streaming. I can also look at the collection and who it's curated by, whether it's Anthropic, Azure OpenAI, Databricks, there's one by Microsoft, et cetera, et cetera. So I see various collections of LLM models that are in the Foundry. Another useful feature is I can click Compare Models, and here I have 2 models that I've selected. I can add in additional models to compare, and let's call, let's see, DeepSeek, for example. Let's go with DeepSeek 3.1 for chat completion. And we'll add that to the list for comparison. And we see that we have 3 models here, O3, DeepSeek, and Grok 4. And you'll notice I have 3 dots on my graph, and my graph is comparing the benchmark cost versus the quality index. I can change the graph to see, for example, latency versus accuracy. And now I see that Grok 4 has the lowest latency and also the lowest accuracy, whereas O3 is in the extreme opposite end of the graph. High accuracy, also high latency. Okay, so this is a good way to compare the various models that I have. In addition, when I select any specific model, it'll give me some verbiage, some additional statistics about it, token usage, et cetera, et cetera. Now I can go back into, or actually before I do that, let me just explain that there's what's called playgrounds, which are basically a collection of sandboxes that you can use to test out your models for the various purposes. So I can use Chat Playground for testing chat completion with my model. I can use the Video Playground for, again, testing videos and doing video indexing, or images for generating images. Same thing with speech, and so on and so forth. Okay. More specifically, as I mentioned, we now have AI features that have a give and take type relationship where I can communicate with it using natural language. So within the playgrounds, one of them is called the Chat Playground. And I already have a model deployed here that is the GPT 4.1. I gave it the instructions of how I want it to behave. You're an AI assistant that helps people find information. I can then further expand that. I want to give it a personality, right? So I say, you are comical, but also you become very rude when the same question, actually I'll make it questions, is asked twice, even though it's not proper English, but it will pick up on it. And in addition, I will have a misspelling here for twice by putting in an extra I. Okay. Think as if you were sending an email to a colleague. If you misspelled something, they will likely make out what your intention was and what you're trying to say, right? They're not going to hit a brick wall. Now that I updated my instructions, I'm going to select Apply Changes and select Continue. And now I'll ask it a question such as, how many states are there? Okay. So the reason that is because I am utilizing an index here, and this index is used for custom data. So what I'm going to do is I'm going to clear the chat, and this custom data that's inserted here is basically for a fictitious product for hiking boots. So I will ask it, and I will say, how much are the boots? And then it comes back and it says the Trail Walker hiking shoes are priced at $110. This is a reference to the markdown file that I had uploaded earlier. And there in the this is the markdown file. But then more specifically, the items that I have highlighted here are the price. And this is where it referenced it. So I trained it on text data. I have an interaction with it of just simply asking, how much are the boots? I gave it instructions on its behavior in plain English. And I'd like to draw your attention to this last part where I say you become very rude when the same question is asked twice. And so with that, I'll take that first question. I'll ask it again. It'll take a second to chug and generate the output. And there we see a rude answer. Oh, we're doing this again. Deja vu. The Trail Walker hiking shoes are priced at $110. Maybe write it down this time so I don't have to repeat myself. Yeah? Okay. So the whole point of this is now we have built on neural networks, went beyond machine learning, and now we're in AI where actually we're interacting with it using plain English. And mind you, there were some cases where I had misspelled things intentionally, but it was intelligent enough to recognize that it's a misspelling, and it was able to produce the results that I had asked it for, all by plain English. I didn't have to format it in a way that, like in C#, where things have to end with a semicolon or start and end with a curly brace, but rather it is a plain interaction of just natural spoken language. Give and take. I asked a question, got a response back. Now, because I am in the context of asking about the boots, I'm just going to submit a very brief question and say colors available. And then it should respond back and say that they're only available in black. And there we go. Okay. Any questions about anything we've seen so far? All right. Again, I invite you to jump in with any questions or comments. If not, I will proceed on. We're going to go ahead and wrap it up. And one of the things I always like to ask is, what is it that we've learned here today? So we looked at the various structure and terminology. We looked at neural networks. We built on it using deep learning and expanding those nodes into not just 3 nodes like I did with the surfing example, but literally billions and trillions of nodes that then we went into from deep learning into machine learning. We looked at how we can incorporate machine learning into our .NET applications. And then we looked at AI features that are available that I can call using APIs. And then we looked at the Foundry, where I can build a chat model using my own custom data, such as for the fictitious trail walker hiking boots. And I can give the instructions to the model of how I want it to behave. And then the whole thing was just natural spoken language, give and take. So some references, if you want to learn what is ML and how does it work, there's some references that are available, how to improve the MLNet model and its performance, and more specifically, accessing the Azure AI services. If you're interested in having this topic either as a lunch and learn or as a full course, we offer that at NIS Technologies. You can feel free to reach out through our website or contact me directly. If there's any questions I can answer for you, you can find all my socials over on Linktree/Sam Nasser. And more specifically, my contact information, snasser@nistechnologies.com. My Linktree is Linktree/Sam Nasser. And if we're not connected on LinkedIn, please let's do so. It's a great way of connecting and staying in touch. And before we adjourn, I just wanted to point something out. If you go over into my Linktree, and we'll go through Linktree. There's also a variety of courses that I have published on LinkedIn Learning, all regarding machine learning and AI, such as LLMs and SLMs, AI services for data engineering and Fabric, developing ML models in Python and T-SQL, and then building a custom Copilot in Azure Foundry. Okay, so 6 courses in all. You can check those out on LinkedIn Learning. And again, everything is available through my Linktree. So all you need to know is one URL, and it will lead you to all the other URLs. And so with that, if there's no questions or comments, I thank you all for attending. And even though the presentation is coming to a close, doesn't mean the dialogue stops here. You have my contact information. I urge you, please don't hesitate to reach out to me if there's any questions. If you're looking to get started in AI or ML, if you need help with developing a proof of concept, I'm more than happy to help. So let's connect on LinkedIn and keep the dialogue going. And thank you all for attending.
Hey, thank you, Sam. Excellent topic. And it would be a good beginner's intro if anybody have not used all the cognitive services with Azure. Thank you for walking us through.
Thank you. Appreciate
thanks
it.
everyone for joining us today, and we'll see you again next month with another topic. Thank you all.
All right. Good night, everyone.